All right, just let me know if you can see my screen.
Yes, we can.
Perfect. Thank you so much for the introduction. I want to talk to you today about this concept of developer-first security, meaning we want to push more and more of the responsibility of security into the hands of developers. And what does all that mean? At Snyk, we believe you can have the best of both worlds, actually. Develop fast, continue with your multi-day deployments, but do it in a secure way. So I'll show you how. That's really the essence of the talk here today. So you may have heard of this term shift left. If you haven't, it's really about pushing the security concerns for application development to the very far left, where the developers are actually writing the code in the tools that they use every day. By doing this, it's going to be cheaper and easier to fix rather than sort of the alternative, which is doing it after you deploy to production. But that in itself is actually not enough. And if you look at traditional security platforms out there, they focus more on detecting and reporting on vulnerabilities, creating sort of an audit style report, enabling application security teams to build gates in the development process to stop them releasing vulnerability into production. That's okay, but the problem with this is it sort of runs counter to the fast, iterative, multi-deployments a day DevOps processes required for companies to innovate today, and therefore sort of slows down development, creates competitive risk, or even worse, is worked around, creating unnecessarily security risk as well. So what we want, a successful approach, is to enable security to be built in continuously, aligned with that iterative DevOps model, i.e. in your CI/CD pipelines. And the responsibility for security has to be initiated from development itself, with the application security team providing or acting in a supporting, advising and governance role in order for that model to scale. This is very similar to what happened for DevOps, in the birth of DevOps 10 years ago, where the operations team sort of adjusted and passed some of the control over developers and tried to figure out, what was their role within DevOps. The same thing is happening now with security and DevSecOps. And a survey, I should say, was conducted titled DevSecOps Insights 2021. And 81% of folks who responded to that survey said that developers should own this responsibility. But the biggest problem they faced was actually how to implement and change the culture such that developers could take on that ownership. So that's what we're going to talk about today, is how you actually shift the security and responsibility to developers, but continue to still drive innovation. So what constitutes an application has changed. I think we know that when we're moving into the cloud deployments. But I guess, indulge me for 20 seconds here. What is the actual impact of all of this? So migrating to the cloud, changing the style of application architecture to cloud native, digital transformation. What is the impact of that from a security perspective? If you look at pre-cloud, developers mostly focused on writing their code and using various frameworks and libraries to construct applications, and then they would throw the application over the fence to operations. And then it was largely the sort of IT and platform teams' responsibility to manage the infrastructure and the technology stack that those applications run on. But if you fast forward into the sort of cloud era, developers touch much more of the application context now, including some of the infrastructure and deployment aspects, things like containers, infrastructure as code scripts, Terraform, CloudFormation, Kubernetes configuration as well. So the scope has changed for developers. And because of that, has increased the responsibility, not only to make sure those things work when they get deployed to production, but make sure they're also secure. Developers are also thinking about things like threat modeling and threat vectors when they're writing the code versus, when things are in production. So the world has changed from a development point of view. And there's a new risk profile associated with building modern applications. If you look at sort of the tip of the iceberg here, that's the custom code or the proprietary code that developers write. But that's only really sort of 10 to 20% of a total application. There's a whole list of assets that developers need to worry about under the iceberg. For example, about 80 to 90% of most modern applications are made up of open source libraries used to construct the applications. And even like a small application of 100 lines of code could in fact import thousands of lines of code from the internet through open source usage. Most of the vulnerabilities exist within what we call the indirect or transient vulnerabilities. That is, if you import a library, that itself will import other libraries. And the problem there is developers simply don't know what they're actually downloading and running with their applications. There's all sorts of nasty malware and vulnerabilities hidden in the open source ecosystem. I'll give you a couple of examples later as well. Most modern applications, of course, will be deployed on modern infrastructure like containers. And developers are simply unaware of the inherent risks of using different base images from, say, Docker Hub, where there's potentially lots of vulnerabilities in the Linux distributions themselves. And finally, which is said to be sort of the #1 cloud vulnerability at the moment, is infrastructure as cloud. And with that, there's the potential of having misconfigurations in your Terraform or your CloudFormation scripts, let's say, or your Kubernetes YAML files, where you're inadvertently maybe using default settings and exposing too much. Developers may accidentally check in secret keys or credentials into the file. They may inadvertently expose various network ports that they shouldn't have. They may be running as root or a privileged user. All of that equals potential attacks surface for hackers to sort of infiltrate your infrastructure. So I really wanted to highlight that applications is not just about writing code. Developers are taking on this huge responsibility of making sure that whatever is needed to build applications such as the open source libraries, the containers, even the infrastructure as code scripts, not only work, but are also secure. So I think you can see that it's a big responsibility for developers. So Snaky Solution works across the full software development lifecycle, going as far left as the IDE itself, so where developers write the code, through the whole DevOps environment, and extending all the way to production, actually. This way, vulnerabilities are found early when it's easiest and least costly to fix them. And this is really how you scale security, by starting from the development in the far left. It also provides several safety points along the way to prevent critical vulnerabilities from ending up in production. We call this stop the bleeding. Many other solutions claim that shifting left, but they only really go as far as the CI/CD. So Snyk started all the way left and actually has expanded to the right. So now we start talking about shift right as well. So if security is shifting left, developers are shifting right. And because of this expansion all the way right, it includes the ability to monitor applications in production, such that if there are any new zero-day vulnerabilities that occur, we can immediately notify our customers and they can patch production environments, even if they've changed their development libraries or their application assets in the development pipeline. They still have obviously a critical vulnerability in production. They need to patch it immediately, so we will notify them of that. So Snyk is very flexible, can integrate into lots of different types of IDEs, VS Code, IntelliJ, Visual Studio, Eclipse, most of the big ones out there. Also into most of the Git repositories, so GitHub, GitLab, Bitbucket, Azure repos, for example, and most of the CI/CD tools as well, things like Jenkins, 𝐶ircle CI, Concourse, etc. But there's a pretty rich CLI and API that you can use to integrate into most pipeline systems as well. So that's Snyk in a nutshell. What I wanted to sort of transition into now is a quick example of how open source can be quite scary out there. This one is called the 𝐂𝐲 malware. A Snyk-led security research found that in the 𝐂𝐞𝐯 mobile application ecosystem, that's the sort of package manager, what developers use to build iOS applications. They identified this Integral Ad SDK, which is from a Chinese mobile ad company. And it was actually stealing revenue from other ad networks. So this SDK, this is the sort of frightening bit, is used in, was downloaded more than 1.2 billion times a month across thousands of different applications. So, you know, the applications that you and I use and download every day. The SDK itself is used for advertising attribution for mobile apps. So developers basically download the SDK into their development environment and they build applications on top of it. And obviously they were unaware of this particular malware. And this obviously was available from the official app store as well from Apple. So obviously quite widespread. But what Snyk found interesting is that the SDK had proprietary obfuscated code that hooked into low-level system APIs on the mobile, which is not that common for a consumer type application. So this is how it sort of alerted the potential suspicious behavior. So what did it do? The code intercepted all HTTP requests to inspect the payload. And that's how it sort of changed a lot of the settings to steal a lot of the ad revenue. To avoid detection, the SDK detected debuggers and jailbroken devices. So when developers were actually developing on it in their desktops, it turned itself off. So didn't have any suspicious network activity. So it became undetected. And what Snyk found is that the SDK installs a backdoor and opens up what's called a command and control instance. So a shell essentially so that potential hackers could remote log into devices out there, obviously to do nasty things. So I just wanted to highlight this in the hope that folks out there start thinking about what open source libraries they're installing or including in their applications. And more importantly, using sufficient tooling to actually detect these things before they launch into production. So with that, I just wanted to wrap up here and give you some homework to do. Go to snyk.io and sign up for free. We have a free forever plan, so you can start importing projects. I would have loved to do a demo today, but we don't have time. But go ahead and if you have a GitHub repository, you can import your projects directly into Snyk. And what we'll do is, depending on what files or source you have in your repository, we will tell you things like your source code analysis. So we'll do the static code analysis right there and then, tell you what issues you have. We'll tell you what open source packages that contain vulnerabilities that you have in your code and give you the ability to do an immediate sort of fix as well. If you have Docker files in your project, we will scan those to tell you what issues you're going to have in your containers. And then if you have things like Terraform or Kubernetes configuration, we'll also tell you if there's any problems there as well in terms of misconfiguration. So try it out. Also, our co-founder of Snyk, Guy Pajani, hosts a podcast called The Secure Developer, which is a fantastic resource. He has a lot of CISOs and application security executives and practitioners on the call to talk about their experiences. So do check that out. He's also written a book called Cloud Application Security, which is a quick read. It's only about 80 pages. You can find it by just Googling Cloud Application Security O'Reilly. It's free, and that should help you if you're starting to think about DevSecOps and how to implement that in your organization. So thanks for listening. You can continue the conversation on Twitter. I'm at Lawrence Crowther and look forward to engaging with you. Thanks, folks. Cheers.